standard scores, also known as z-scores. Okay, you may remember this diagram from a previous video, but what we want to look at now is how to use this diagram to compare different normal distributions together. So if you imagine an example where you did an English exam and the mean was 80 and the standard deviation was 3. We can put this onto our diagram. So the mean is 80, standard deviation is 3, so we add 3, 83, add 3, 86, add 3, 89, subtract 3, 77, 74, 71. Okay, now then we also then go and do a maths exam, our favorite subject, definitely mine. X bar equals 70 and standard deviation. In this case, it's much more spread. So we've got a lower mean and a bigger spread. So we can do the same thing. X bar, we line that up, that's 70, plus 7, 77, plus 7, 84, plus 7, 91, and then minus 7, 63, 56, and 49. This is just your 7 times tables there. Now you can see that if you score 80 on the English, then half the class did better than you, and half the class did worse than you, because that's the mean. But 80 looks better than 70 in the maths, but 70 in maths means half the class did better than you and half the class did worse than you. So actually 80 and 70 are the same, but they look different. And so that's not great. And you can get some even weirder ones. So if you score 70 on the maths, but 71 on English, you might say the English mark is better because it's 71 and 71 is more than 70. But clearly, that's not the case. 71 in English means that only a tiny fraction, only this tiny little fraction of 0.15% of the class did worse than you. Whereas in the maths, you got 70 and only half the class did better than you, not like the vast majority. Okay, so you can see that just looking at the numbers doesn't help you compare. But what we want to talk about then is your position in the class, your position on this axis along here, right? And we can do that. We can convert it into a thing called z-score. So if you imagine the mean is 0, then this position is 1 because it's plus 1 standard deviation, and this is 2 for plus 2, 3 for plus 3, and then what do you know? This one's minus 1, this one's minus 2, and minus 3. So if I said to you my z-score for maths was 0, and my maths z-score, English z-score was 0, then you could see that they would be directly comparable, right? You just say 80 in English is a z-score of 0. So that's what we're calling these things, by the way. That's a z-score. May need to mention that. And so then you'd just be able to compare the z-score with a z-score, and there'll be no confusion. So if I said I got 70 in maths, that's a z-score of 0, but if I got a 71 in English, that's a z-score of minus 3, worse than 0, therefore I can compare them. So that's what we're using z-scores for, and this is why they're called standardized scores. I hope that helps you understand what a z-score is. Okay, so here we've got something that says approximately normally distributed, which means we can do our lovely graph. We've got the mean of 69 and a standard deviation of 4. So we can pop some values on here. We know that's going to be 69 plus 4 plus 4. Keep thinking 4, so it's 4, 81, 65, 61, 57. All right. Now, it says here we want to look for a standardized pulse rate of z minus 2.5. Now, if you think about this, over here we got minus 2 and here we got minus 3. So minus 2.5 is there, right? Halfway between 57 and 61, right? That's minus 2.5. So it's going to be 59, isn't it? It's halfway. So the answer is A. So the actual pulse rate, 59. And you can see how you can approximate these things quite easily. It's just a linear scale on the z-score, so not so hard to work out. Now this is the same data as last question, but it says we want, it don't even need all that, this bit we don't actually even need if you actually read the question. It says we got a standardized pulse rate of z equals minus 1. So remember with your z's, so minus 1 is here, that's 0, 1, 2, 3, minus 2, minus 3. So it says we want the minus 1, and we want the percentage of people that are greater. So that's all this area. A couple of ways to do that. You might know that the rest of that area is 16%. So 100 minus 16 gives you the 84%, which gives you that answer. Different ways to add up all those bits of area, but that's how you do it. So fairly straightforward. Now, this looks like quite an intimidating question, but this is the one you should attack then and know inside out and back to front so that you can do better than everyone else. So we've got our approximately normally distributed. We've got a mean of 78.6 and a standard deviation of 9.3. Now we could put lots of values in this, but it turns out that we only have to talk about Brett, who's Z of minus 0.96. So I'm going to mark Brett on there. So minus 0.96, remember minus S is minus 1 on the Z scale. So that's Brett, very close, probably even closer than I've drawn. That's going to be Brett. And then Sanjeeva is minus 0.26, which is about a quarter. So it's about there. And we're going to put an S for Sanjeeva. And so we need to put some values just maybe on the mean, which we were told is 78.6. And then we're just going to take away one standard deviation, which is going to be 69.3. There we go. All right, now we're going to have the fun of working out which of the following statements is not true. So let's start with A. Brett and Sanjeeva are both below the mean. They've both got a negative Z score, so yes, that is true. So answer A is wrong. Answer B, if you look on the scale, Sanjeeva is to the right, which means more. They're trying to fool you because minus 0.26 looks less than minus 0.96. But if you look on the scale where we've drawn them, you can obviously see that to the right is heavier. So Sanjeeva is heavier. C, if Sanjeeva increases weight by 2 kilos, he would be above the mean weight for players in the basketball competition. That one looks tricky. So what you do is you go, not sure, but if I can definitely get rid of D and E, then it must be C by elimination. And that can be a good technique in an exam. So you put a question mark. And on your exam sheet, you might just come back to this later. So you get yourself down a quick answer, move on to other questions, and then you can come back to this one later if you've got the time, rather than spending a huge amount of time trying to get this mark when you probably would have got it anyway with good elimination. So let's go to D. Brett weighs more than 68 kilos. Oh, Brett does weigh more because one standard deviation subtracted is 69.3, and he's to the right of that. So he's definitely more than 68 kilos. And more than 50% of the players in the basketball competition weigh more than Sanjeeva. Look, you already know that's 50%. And more than that, because there's also this little bit here. So it's definitely true that it's more than 50%. So it's like that. So it looks like the answer is in fact C without having to do the horrible calculation on it. Let's have a look at what we can do there though in terms of actually seeing if we can work out the answer. So if you want to, you can use the formula that the Z score equals X minus X bar over S. So we know the Z score is for Sanjeeva is minus 0.26, so it's minus 0.26 equals the X, we don't know, minus X bar was 78.6, and we divide that by the standard deviation S, 9.3. And if you wiggle all that around on your calculator, I'm not going to show that right now, you'd probably find that S equals 76.2. So when we're actually saying what is the actual weight of Sanjeeva, it looks like it's about 76.2 when you pop it all on the calculator. A bit of rounding there. So if you add 2 kilos to that, you would get 78.2. So you wouldn't actually be going past the 78.6. So it is not true if you add 2 kilos, you go past the mean. There you go. One of the rare occasions where you use that formula. It's not actually that common in past exams. Guess what? Approximately normally distributed. They keep telling you this. and we got a mean of 165 and a standard deviation of 25. Let's put those numbers on there. So we've got 165 plus 25 is 190, 215, and plus 125, that's 230, 240. Hopefully getting that right. Minus 25, 140, minus 25. So look, you know, in your head, you're minus 20, 120, minus 5, 115, and then your minus 25, that's obviously going to be 90. Whew. So we've got those numbers on there, and the question says, what percentage of clusters is expected to contain more than 140 eggs? So if you look at that, they're just asking for what is all that percentage. 68 plus the 16, you've done this all before. That should be 84%. Fairly straightforward, that one. If you just add up the 68 and the other bits. Next question says the number, so we got number, all right, of clusters expected to have less than 215 if you take 1,000 clusters. So we're going to go less than 215, which is all of that area. Remember, this is the easier one, is to say, well, we know this bit is 2.5, so the rest of that is 97.5%. So we want 97.5% of 1,000. That equals, well, 975 if you do the maths. So that's the number. Okay, so this question, we're probably going to need to use our old formula here of z equals x minus x bar over s. Don't often get to use this fella. So this one you have to put in minus 2.4. Why? Because that's our z over here. And we know then that that equals x is the mystery number we want. Where's our mean? Our mean, it was given up here of 165. So we put minus 165, and then we put all that over 25, because our standard deviation is 25, and that's what S is. So we put that over 25, and then you have to rearrange all that in your calculator. I'll show that at the end, how to put that in the calculator. But if you rearrange all that, and if you do all the maths correctly, you'll get that x equals 105. And so determine the actual number of eggs. So remember number, on that 975 before, people often put 97.5 apparently. And you put 105. You might want to put eggs if you like. You don't have to anymore, with not so fussy as the units as they used to be. It says this was answered reasonably well, but actually only 2/3 of people got that right. Just wanted to show you how to do it on your calculator. So you can see it's all set up there. So that was, for the equation, minus 2.4 equals x minus 165 over 25. And that's how you get the answer, x equals 105 in the calculator. You might want to notice, like, what I do is I put the brackets here, like, which would be there. And that's just to keep the numerator all together. And then the slash here is the divide. Now, a good trick is just use that x, the one that's on the front of your calculator. It can be any letter you like, but sometimes just using the x on the front of your calculator might be quicker for you. All right, so just practice. If you're not good at rearranging equations, practice looking at that. And remember to keep a numerator all together, so you don't make any syntax errors. Use the brackets around the whole thing, all right, and then do your divide symbol.